sklearn, model selection, permutation test score. Description. This function performs a permutation test for the given score function on the given dataset. It assesses the significance of the model's performance by randomly shuffling the target variable and evaluating the score on the shuffled data. This helps determine whether the observed score is due to a genuine relationship between features and target or simply random chance. Inputs. Estimator and estimator object implementing fit and predict methods. This is the machine learning model you want to evaluate. X the feature matrix, typically a 2D array. Y the target variable, typically a 1D array. Scoring the scoring function to use. It can be a string representing a common metric, e.g., accuracy, F1 macro, or a custom scoring function. CV the cross-validation strategy to use. It can be an integer number of folds, a CV splitter object, e.g., k-fold, or non-default 5-fold. N permutations the number of permutations to perform. A higher number leads to more robust results but takes longer. N jobs the number of jobs to run in parallel for permutation testing. -1 uses all available processes. Random state the seed for the random number generator. Useful for reproducibility. Outputs. Score the score obtained by the estimator on the original data. P-value the p-value of the permutation test. It represents the probability of observing a score as high as the original score if there were no relationship between features and target. Steps. The function first calculates the score of the estimator on the original data. For each permutation, it shuffles the target variable and trains the estimator on the shuffled data. It calculates the score of the estimator on the permuted data. It repeats this process for the specified number of permutations. The p-value is calculated by comparing the original score to the distribution of scores obtained on the permuted data. A low p-value suggests that the observed score is unlikely to occur due to chance. Metrics. P-value a measure of the statistical significance of the model's performance. Visualization plots. Histogram or distribution plot of the scores obtained on the permuted data, with the original score highlighted. This helps visualize the significance of the observed score. Fine-tune parameters. N permutations increase this value for a more robust test but at the expense of computational time. N jobs increase this value to leverage multiple cores and speed up the permutation process. Uncertainty methods. The permutation test itself is a method for quantifying uncertainty, as it measures the probability of observing the observed score by chance. You can also use confidence intervals based on the distribution of scores obtained on permuted data to assess the uncertainty of the original score. Challenges and fixes. Challenge 1 high p-value indicating the model's performance might be due to chance. Sample use case that resulted in challenge 1 a model with a high accuracy on a dataset where target variable has little correlation with the features. Fixes to challenge 1. Consider using a different model or feature engineering to improve the relationship between features and target. Re-evaluate the dataset and ensure that the target variable is meaningfully related to the features. Challenge 2 long computation time for a large number of permutations. Sample use case that resulted in challenge 2 permutation testing with a large dataset and a high number of permutations. Fixes to challenge 2. Reduce the number of permutations if the time constraint is a major concern. Use a smaller sample of the data for the permutation test if the full dataset is too large. Utilize a parallel computing framework to distribute the permutations across multiple cores.